Hey there, statisticians. In our last video for 9.2 lesson, let's talk about the power of a test. So when we say power in these tests, what I mean is the probability that the test will find convincing evidence for an alternative hypothesis when I already know one specific value for that alternative hypothesis. Okay? So I am going to say like my 80% shooter. Remember, he shot 64%. So what is the probability that I am going to find convincing evidence to reject the fact that he's an 80% shooter when I already know he had a 64% stretch? That's what we're saying. So a power test allows us to answer the question, how likely is the significance test to avoid a type 2 error? So power is how likely are we to avoid a type 2 error. And remember, type 2 errors are when our sample gives us a large p-value when in reality the population is a small p-value. The power of a test is a conditional probability. Remember our conditional probability, this is read, what is the probability that I reject the null hypothesis given that a parameter is a specific value. So I am going to say the free throw shooter shoots 64%. So what is the probability that I will reject that he's an 80% shooter? So what's nice is you're not going to have to figure this out. All right, you're not going to have to calculate it, but you are going to have to interpret it and talk about ways to increase that power. So you're going to have to worry about the interpretation and ways to increase power. That's where our focus is going to be. So let's relate power and type 2 errors, how they go together. So the power of a test to detect a specific alternative parameter value, the 64% shooting stretch, is related to the probability of a type 2 error for that alternative. So power is 1 minus the probability of a type 2 error. Or you can say 1 minus power is the probability of a type 2 error. So if I want to increase the power of a significance test, the power of a significance test, that's our when we use our alpha and we look at all of how likely are we to reject our null hypothesis. So the power of a significance test to detect an alternative value of the parameter when the null hypothesis is false and the alternative is true, based on a random sample size of n and a significance level alpha, will be larger. So if you do these three things, you will increase the power that we are of our test. So we want to increase the power. To increase the power, we will do one of these three things. Okay. So let's take a look at this. We talked about this example the other day in class. You are thinking about opening a restaurant and are searching for a good location. From the research you have done, you know that the mean income for those living near the restaurant must be over $85,000 to support the type of upscale restaurant you wish to open. You decide to make a simple random, wait, I'm missing something. Where is it? So we're going to, so based on the mean, I didn't need this part. So based on the mean income of this sample, you will perform a test at the alpha level of 0.05 significance level, our null hypothesis versus our alternative hypothesis, where mu is the true mean income of the population of the people who live near the restaurant. The power of the test to detect that mu is 86,000 is 0.64. Interpret this value. So power, if we go back to here, power is 1 minus the probability of a type 2 error. So 1 minus the probability of a type 2 error is 0.64. What that means, if the true mean income for all people in the population near the restaurant is 86,000, because that's greater than the 85, I am given an income right here. This income is greater than 85, so that it is my alternative value. There is a probability of 0.64 that convincing evidence for the alternative hypothesis will be true. Okay, so I know what this probability is. I already know one value that for the alternative hypothesis. So what is the probability that other values exist? That's what we're saying. So when researchers, and that's us, we are researchers, we're statisticians, we plan a significance test to analyze our results. We're often going to calculate the sample size needed for a desired power. We want to know the sample size we should use. We don't want to get a too large sample size because that takes more time and money, and we don't want one too small because then my results won't reflect the population as a whole. For a specific study design, the sample size required depends on 3 factors. Significance level, that's our alpha. How much risk of alpha, remember, alpha measures the probability of a type 1 error. How much risk of a type 1 error, that is rejecting the null hypothesis when it's actually true, are we willing to accept? If a type 1 error has serious consequences, you might opt for a very low alpha level. Otherwise, choose 0.05 or 0.10. I like 0.05. I think that's always a good one. Recall that using a higher significance level would decrease a type 2 error probability and increase the power. Effect size, how large a difference between the null parameter value and the actual parameter value is important for us to detect. How far, what's the space between what we think should happen and is actually going to happen? And what probability do we want our study to have to detect a difference of the size we think is important? Most researchers insist on a power of at least 0.8 for significance tests. Alright, so I am going to help you with some of these examples in 9.2, some of these exercises. If you have any questions, please let me know.